Hello everyone, today I am going to discuss about the data mining clustering analysis. The data mining clustering analysis in the R usually consists of the four different techniques. There are the k-mean clustering technique and k-mediate clustering technique and hierarchical clustering technique and density based clustering. The first three, that is k-mean clustering, k-mediate clustering and hierarchical clustering, are used to cluster the data. Whereas the last one, density based clustering, is usually used to create a new label data by using the algorithm dbScan algorithm. Now coming to the R software functions, the R software functions, the data set for me is the tiger data set. That it consists of different breeds of tigers and their weight and height and length of the tigers. These are different types. There are four types of tiger breeds, that is Bengal tiger, Sumatran tiger, Siberian tiger and South China tigers are used in my data set. Now coming to the k-mean algorithm, k-mean clustering. For the k-mean clustering, I am going to create a mirror data set as tiger2. In the mirror data set, I am going to eliminate the tiger breed column from it so that I can plot a cluster results by using the using the weight, length and height of the data set. Now coming to the clustering, k-mean clustering. Yeah, here you can see I have eliminated the data's tiger breed column by using the function as tiger breed null. Now I'm going to do the clustering by using the k-means algorithm. I have plotted the tiger2. This is the plot for this. Yeah, here it is, plot. Now coming to the clustering algorithm, by using the k-mean clustering, I am going to find out the k-mean results. By k-mean results, now here is the table. By using the table, I can say that the Bengal tiger can be easily separated from the other clusters. Whereas the tiger breed like South China tiger and Sumatran tiger are they can say that they're small degree overlapped with each other. Now coming, I am going to plot a cluster analysis. We are going to clustering for this by using the two dimensions, that is height, length and height, from the column 1 2 3, that is and by using, I am going to plot it here. Okay, but then I am going to get the k-means plot for this. Then I am going to use the k-mediate clustering. The k-mediate clustering is usually uses the two functions, that is PAM and PAM-K. PAM and PAM-K. It is functions that are used actually these are used to perform the this k-mediate is robust than the k-mean clustering, because the k-mediate clustering is represented as with the object closest to the center of the clusters in the mediate clustering. Now coming to the k-mediate clustering, by using the library command, library fpc and library cluster, I am going to PAM-K results. This here you can get the PAM-K results, the list of 3. Now I am going to table. I am going to get the table of the by using the PAM-K results. PAM-K result. Now I am going to plot by using the Taylor, and to plot the 2 graphs per page. Yeah, here I can see there are the 2 graphs, 2 plots. The left one, it is known as the clus plot, known as the clustering plot. The right one is known as silhouette plot. The right one shows there are the large SI. It suggests the corresponding observations are very well clustered. The small SI around 0 means that the observation lies between the two clusters, and the observation with a negative SI are probably placed in the wrong cluster. You can see the negative cluster, you can see the long cluster. Since the average SI are respectively, for me it's 0.832 and 0.62. in the above Silhouette, identify two clusters are well clustered. Now next I'm going to try the PAM with K value equals to 7. By using the K value equation, the K value gives the cluster tree. I'm going to plot the PAM results. By using the cluster tree, I got the cluster tree. Here's the value. The line here, it shows the distance between the clusters. These are the three clusters. I'm going to plot. Then I'm going for hierarchical clustering. The hierarchical clustering demonstrates with using the function hclust. We first draw in the hierarchical clustering. We first let me taking the full data. Let me plot the hclust. This is the cluster dendrogram by using the total data. I really look clumsy here because all the data set are at once. Now for this now I'm going to take a sample. I have taken the sample of 30. Now I'm going to plot the 30 sample. Going to 30 sample. Here we can see I have plotted the cluster dendrogram doing the H sample. Yeah, see here is for the 30 samples, and that I am going to 7 clusters. I am going to decide into 7 clusters. Here you can see these are the 7 clusters. 1 2 3 4 5 6 7 cluster dendrogram. I'm going to K value equals to 7. Then after getting the PAM results, PAM K results by using the sample, and now I'm going to do the density based clustering. The density based clustering is based on the numerical data. The idea of the density based clustering is to group objects into one cluster if they are connected to one another by densely populated area. There are two key parameters in density based scan algorithm, which is known as DBSCAN. The two main parameters are EPS and minimal point. The EPS value, the EPS is the reachability distance, which defines the size of the neighborhood, and the minimal point is the minimum number of the points. If the number of points in the neighborhood of the point is alpha is no less than minimal point, then alpha is a dense point. All the points in the neighborhood are densely reachable, and alpha is put into the same clusters. The strength of the density based clusters are that it can discover the cluster with various shapes and sizes and is insensitive to noise, as comparison to the k-means algorithm tends to find clusters with sphere shape and with similar sizes. By using the below functions, we can find out, here just a minute. By using the function library function FPC, I'm going to plot. Here you can see the index values, DS list of tree, the groups. Okay, I'm going to set seed for 435 index. Now I'm going to plot a new data by using the cluster analysis, by using the DSSCAN algorithm. By using this, I'm going to get the new data points on the. I'm going to plot a graph by using the two dimensions, is length and weight of the dimensions. By using this, we can cluster analysis. We can find out. We can do randomized noise. The clustering model can be used to label new data. Based on the similarity between the new data and the cluster, by using these functions, I have used the 10 objects as my sample, 10 objects from the Tiger data, and add small noises to them to make a new data set for labeling. The random noises are generated with the uniform distribution by using the function runiform. Here we can see the runiform function. I have generated the new data. This is the plotted the new data. Here this is the new data set. Even we can do the prediction for the data set here by using that my predict analysis. By this we can get the analysis. Here by using this we have in my project, by using I have implemented the 4 types of clustering techniques and I have solved them to get the desired result. That's all for today. Thank you everyone for your